So today's lesson is on conditional probability. You can see here that this is how we write conditional probability. The probability of B given that event A has already happened. So an event in probability could be, flipping a coin, rolling a die. Those are events. And so if you know the probability of one event, then given another event has already happened, that's how this works. So you'll see this on the SAT. You'll see this on some other kinds of tests, on my test. The table shows the students by gender at 2- and 4-year colleges and grad schools in 2005. You pick a student at random. And so here's a table of information. You have some 2-year, 4-year, and graduate school students, some males, some females, different breakdowns. So it says, what is the probability that is a female given that you were talking about someone who went to graduate school? So I think the given information here is graduate school. So what I like to do is highlight the given information. Graduate schools, I'm only talking about these people. I'm not talking about any of the 2- or 4-year college people for this thing. So when we look at probability, this is going to be, total outcome. So if you add these two numbers up, let's see, that's going to be 3,540, 3. I think that's 3,303 when I add up those two numbers. That's the grand total of all the graduate school students. And then how many of those 3,303 are females? That would be 1954. And then you would type that in your calculator and you would get the probability of the answer. And so I'll let you do that, type it in on your own. And so let's look at another question here. Oops. So what is the probability that you are 4-year given that you are male? So now we are only talking about the males. So here we're talking about this column of data here. So we're looking only at these folks. We're not looking at any of the females for this one. So to set up our probability here, in the numerator would be the 4-year males, so that would be 4324. In the denominator, I'm not going to use my calculator, I'm just going to tell you how to get it. You would add up the 1866 plus 4324 plus 1349. So you're adding up all of the, again, in this case, our given information is males, so this is the total of all the males down here, whereas this 4-year is only the male 4-year students. And then that would give us our probability. You would type that in your calculator and get an answer. Let's try another one. Some more information here. What is the probability that a sample of recycled waste is paper? So really it says it in a different way, but the given information is that we are talking about a sample of recycled waste. That's given. What's the probability that a sample of recycled waste is paper? So the given information is recycled, so I'm only looking at this information here. So I want to see if it's paper, so that would be, the fraction would be 45.2 divided by, and then you would just simply add up everything in that column. So 45.2 plus 7.2 plus, this is the grand total of all the recycled, plus 2.1 plus 21.7. And then type that in your calculator and you get an answer as a decimal there, which would be fine. This is where it starts to get complicated. So given any two events A and B with probability of A not being 0, what is probability of B given A? So this is the formal way of doing it. So let me do it the formal way, and then we'll do it the way I just taught you a minute ago and see which way you like better. So what is the probability of A and B happening? So first of all, let's consider what A and B are in this case. So if the formula is probability of B given that A has happened, in this one, what is the probability that the customer pays the bill online given that the customer is male? So in this case, what is the probability that you pay online given that the customer is male? So I just want you to make sure you know that the pay online is your B in this case, and your given information is A, right, is the male. So in this case, to plug into the formula here, it says that all we need to do is probability of A and B. So what is the probability of A and B? What is the probability that you are paying online and male? So paying online and male, there are 2 people who do that. So in the numerator, it's going to be 2 divided by the grand total. If I add up all these numbers, that's 20, that's 30, 20 and 30 is 50. So 2 out of 50 people are male and online. So that's A and B, male and online. What is the probability of A? A is really male. So what's the probability of being male? So how many males do we have? We have a total of 20 out of a total of 50. Dividing by a fraction is the same thing as multiplying by its reciprocal. So we could write this as 2 over 50 times the reciprocal of 20 over 50, which is 50 over 20. Cancel that out, you get 2 over 20, which is, what, 1 over 10? 4.1. You can write it either way. Really, either way is acceptable there. Except fractions and decimals in that case. Now, that's the formal way of doing this problem. Now, if you wanted to do it more informally, like we've been doing it a minute ago, let's just figure out what the given information is. Given that customer is male, so the given information is male, I'm only looking at those folks. The fast way of doing this, well, what's the total number of males? That would be 20. And I want to pay the bill online, so that would be 2 out of 20, which is 1 out of 10. It's faster doing it the other way, just kind of thinking, okay, what's the given information? That's the pool of people I'm choosing from, and what's the probability of picking that certain type of category. Finally, we get to tree diagrams, and these are definitely a little bit different here. This is our last problem, I believe. So we're going to draw a tree diagram. Well, the main thing I want you to know before we start this particular problem, if you do a tree diagram, let's say you have 2 branches. If this one's 70% or 0.7, then this one would have to be 0.3. In other words, these 2 have to add up to 1. The branches, if there were 3 branches, and this one was 0.2, and this one's 0.7, this one would have to be 0.1. Does it make sense? Like these are going to add up to 0.7 plus 0.2 plus 0.1 is 1. So they're going to always add up to be 1 each time you have a group of branches like that. So let's try a problem and see if this kind of makes sense. So the base thing here, school system follows a survey sent to people who were juniors 10 years earlier. 85% of the students graduated from high school. So let's start with that fact. So let's make a tree diagram with just that fact. So we think 85%. So I'm going to write it this way. Let's see, graduated high school. And this one would be not high school grad. So it's the opposite. So you either graduated or you didn't graduate. Those are the 2 options. The probability of this happening, it says, is 0.85. So 0.85, 85% of folks, so 0.85 graduated high school, which means by default, it doesn't say it, but you know that 15% did not graduate high school. Okay, of the students who graduated, so let's talk about these folks, 90% are happy. So now there's 2 groups that go off this. There's 2 branches here. So these are happy folks, or some folks are happy. In fact, it says that 90% is very encouraging. 90% or 0.9 people are happy who graduate high school. And not happy, well, that's not very good for those folks. Not happy, and that would be, since that's 90%, this would have to be the other 10% here, so 0.1 would be the decimal. And then it says, of the students who did not graduate from high school, 60% are happy. Oh man, that's so sad. So only 60% of these folks are happy. So happy is 60%, so this is 0.6. And then not happy, and that is going to be 0.4. Let's see, 0.4. Okay, So to figure out the probability of each branch here, which really is helpful in answering this final question, I'm going to figure out the probability of each branch. So what's the probability that you both graduate high school and are happy? To get that, all you do is type in 0.85 times 0.9, and you're going to get an answer in your calculator. To get the probability of graduating high school and not being happy, 0.85 times 0.1, type that in your calculator. To figure out the probability of not graduating high school and still being happy is 0.15. I think that you graduate high school, you've got a better chance to be happy, it sounds like. And finally, not graduating high school and not being happy, that's not a good situation. 0.15 and 0.4. So type those in your calculator. So I typed all these in my calculator. These are the 4 answers I got. By the way, if I add up 76.5% plus 8.5% plus 9% plus 6%, I would get exactly 100%. These are always going to add up to 100%. Now let's answer the question that was asked. What is the probability that a person from the junior class 10 years ago graduated from high school and is not happy with his or her present job? So graduate high school and not happy, that would be 85%. Let's ask a more difficult question just for fun. So that's the answer to that question. So if the question was, because I'll see this sometimes, given that you are happy, what is the probability that you graduated from high school? So let's figure that out. So given that you're happy, well, which of these 4 are happy people? Well, 76.5% of people are happy who graduated, and 9% of people didn't. So if I add those two up, that's 76.5. 76.5 plus 9 is 85.5%. So in the denominator here, we have 0.855. Now, what's probably that of those folks, that's all 85.5% are happy, but I only want the folks who graduated high school, so that would be 0.765. So then I would take 0.765 divided by 0.855, and you get 89.47%. So 89.47 percent is the percent of folks who, given that they are happy, graduated from high school. So that's how you figure out conditional probability.